Hi, welcome to our fourth video on polar form for complex numbers. We know complex numbers can be written either rectangular or polar form. And on the Argand diagram, in polar form, we talk about real and imaginary components. And in polar form, we talk about a modulus r and an argument theta. Okay, in this video, we're going to explore how to raise a complex number to a power in polar form. And here's the rule we're going to learn. If the complex number z is equal to r cis theta, then to raise z to the power of a number, we go r to the power of the number, cis, and then we go in theta, which means in times theta. So we don't raise the argument to the power, we just times it by the number in the power. Now this rule has been named after a mathematician, de Moivre's, and it is called de Moivre's theorem. So let's get straight into example 1. If w is our complex number written in polar form 4 cis 50 degrees, we're going to find w to the power of 3. So let's pop down de Moivre's theorem here. So w is 4 cis 50. We're finding w to the power of 3. So to work out w to the power of 3, we go 4 to the power of 3. We write down cis, but we don't go 50 to the power of 3. We go 3 times 50. So 4 to the power of 3 is just 4 times 4 times 4, which is 64. And then we write down cis, and 3 times 50 degrees is 150 degrees. All right, well, let's move on to a second example. If z is a complex number and it's equal to 4 plus 7i, we're going to find z to the power of 5. Now notice z is in rectangular form. And if you really wanted, a power of 5 means to multiply by itself 5 times. So if you're really keen, you could multiply out 4 plus 7i times 4 plus 7i plus 4.7i and so on 5 times. It might take you a wee while to multiply out those 5 brackets, but you would get there eventually. I don't feel like doing that. I'm going to show you a different way to do it. And I'm going to use de Moivre's theorem once again. But what it means is I have to change z back into polar form. And you may hopefully remember how to do that. Keep revising those basic techniques. You need to find the modulus, which is the distance away from the origin using Pythagoras. And I get 8.062. I've rounded that to 4 significant figures. And then I get cis. And then I get my argument, which is the angle rotated anti-clockwise. And I'm working in radians here, so I get 1.052 radians. All right, now I can use de Moivre's theorem. That simply says to raise a complex number to a power of 5, I'm going to go 8.062 to the power of 5. Then I write down my cis, and then I go 5 times 1.052. So I get my calculator. What's 8.062 to the power of 5? It's 34,057, and I'm rounding it to 0.6. Then I pop down my cis, and then 5 times 1.052 is 5.26, sorry. Right, so there's my final answer, 34,057.6 cis 5.26. Remember, I'm working in radians, so I don't need units for 5.26. But remember, this is in polar form. It's okay if you leave the answer in polar form because you don't need to change it. That's fine. But if you do need to change it back into rectangular form, let's quickly remind you how to do that. It's 34,057.6 cosine of 5.26 plus I times 34,057.6 times sine of 5.26. And don't forget, because I'm working in radians, flick your calculator across to radians, and I get 17,732.1 is my real bit, and minus 29,077.4 imaginary bits. Awesome. Thanks for watching.